All right, how's everybody doing? Hanging in there? I hope so. We're going to finish up problem number 5 from our solving trig equations review. All right, so here we are. Problem number 5 says solve the equation in the interval 0 to 2 pi, and we've got 2 tan theta sine squared theta equals tan theta. Now, one of the things you want to recognize is that both sides of the equation have a tan theta in it. Do not, because this is a common mistake, a lot of times people say, oh, well, let me just divide out the tan theta. And that is incorrect because you will end up getting rid of some of your potential solutions. So instead, the correct way to solve this problem is by taking tan theta and moving that over to the left-hand side. That'll give you this piece right here, 2 tan theta sine squared theta minus tan theta equals 0. From here, you want to recognize that there are 2 terms that have tan theta, so factor out a tangent of theta. That'll result in tan theta times the quantity 2 sine squared minus 1 equals 0. Simply set each one of your factors equal to 0 and solve. For tan theta, you end up with 0 and pi. But for sine squared theta equal to 1/2, we've got to go a little bit further. You're going to have to take the square root of both sides. Now be careful. Make sure that you take plus or minus the square root of 1/2. Don't just take the positive, but you need both positive and negative. Now when you rationalize the square root of 1/2, you'll end up with root 2 over 2. So your solution is going to be sine theta equals plus or minus root 2 over 2. Now there's values on the unit circle that correspond to that, and they are all in the pi over 4 family. Now we'll take all of those solutions, of course, and we'll write them in order. So your final solution for this problem is theta equals 0, pi over 4, 3 pi over 4, pi, 5 pi over 4, and 7 pi over 4. See, that wasn't that bad, was it? All right, thanks for watching, and I'll catch up with you guys really soon when you take a look at problem number 6. Until then, peace out.